Yeah. So, hello, students. Good afternoon to all. Can you hear me, see me, and is my screen visible to all of you? Just give a thumbs up or let me know in the chat box if you can hear me and see me. Yeah, good afternoon, Shiva Shankar. Good afternoon. Good afternoon. Can all of you hear me? Am I audible to all of you? Yes. Okay. Okay. Thank you. Thank you so much, Shiva Shankar. So, I hope you are all good and safe. So after a long period of time, after a week, we are meeting again. So in the last class, we have started hydrocarbons, right? So I hope you all can able to recall it. So before starting the today's session, I would like to ask some questions to you. So just to recall it as a recall test. So all of you can try for it and put the answer in the chat box. Okay, some two questions, very easy only, very easy questions. So just for the recalling purpose, you don't have to worry or you don't have to get scared of it. Okay. So what is the general formula for alkanes? What is the general formula for alkanes? Can anyone answer for this? Yeah, yeah, the person who is behind Samsung Lab 2 device, you have raised your hand, it seems. Yeah, give me the answer in the chat box. What is the general formula for alkanes? All of you can try. Such an easy question, right? So we have discussed about the alkanes and the introduction to alkanes and IUPAC nomenclature of alkanes and isomers and what else? Yeah, isomers we have studied about for alkanes. Yeah, CnH2n plus 2. Very good, Shiv Shankar. Good. So the answer is CnH2n. So one more question I have for you. It is also very easy. So it is there on your screen. What is the hybridization of carbon in CH4? What is the hybridization of carbon in CH4? Try for it. Try for it. Such an easy, very easy question. What could be the correct answer for this? While discussing the structure of alkanes, by taking CH4 as an example, we have discussed this, right? So what is the hybridization of an alkane? Sp or sp2 or sp3? What is the correct answer? Sp, sp2, sp3. So among these three options, which is the correct answer? Very good. Very good. sp3 is the correct answer. So the hybridization of carbon in CH4 is sp3. Okay, very good. Very good. So I wish all of you can try for the answer. Okay. So just be interactive in the class. So you don't have to get scared of attending the class or seeing me. Okay. So moving on to today's class. So today we are going to discuss the preparations of alkenes. So we have studied all the introductory part of alkenes and the nomenclature of alkenes and isomerism of alkenes. Okay. Now those three topics are over for alkenes. Now fourth topic for alkene is preparation. We are going to prepare these alkenes and then we are going to study the physical properties and chemical properties of alkenes. Okay, so with this chemical properties, the topic alkenes topic will get over. Okay, so moving on to the first topic for today's session, that is the preparation of alkenes. So there are three preparations you have already seen in the previous slide, right? So the first preparation is from unsaturated hydrocarbons. Okay, this reaction is also called as hydrogenation. Now, how we are going to prepare this alkane from unsaturated hydrocarbon? So we all know that unsaturated means the compound which contains carbon-carbon double bond and carbon-carbon triple bond, right? Those are unsaturated. From that, alkenes and alkynes only we are going to make or we are going to prepare alkanes. Okay. So the name of this reaction is called catalytic reduction. Means we are going to use a catalyst and then we are going to reduce the unsaturated compounds. Okay. So you can see the general reaction here. So an alkene is taken, and to this alkene, a hydrogen is added, hydrogen molecule is added using the catalyst. Who are the catalyst? Platinum, palladium, and nickel. So all these are metals. Okay. So platinum is a metal, palladium is a metal, and nickel is a metal. So you have to use either one of these. You don't have to use all the three. You are going to use just one among the three catalysts, which are basically the D block metals. They are the D block metals. So using the catalyst, we are going to add the hydrogen. So addition of hydrogen is called as a reduction, right? So that's why it is called as catalytic reduction. And because of this addition, we are getting an alkane with the CnH2n plus 2 formula. Got it? Now, in the same way, alkynes are also called as unsaturated compounds, right? So to this alkyne also, we are going to add hydrogen. But in alkyne, if you want to make alkane from alkyne, you have to use 2 moles of hydrogen. What you have to do? You have to add 2 moles of hydrogen to alkyne to prepare alkane with the same metal catalyst. Got it? So I'll show you some examples for this. So here are the examples. So ethene is taken as an example for you under alkene category. So to this alkene, we are going to add the hydrogens. How to add the hydrogen? Just break one of the double bond, add one hydrogen to the first carbon and another hydrogen to the second carbon. So you will get ethane. Okay, CH3 bond, CH3. So one more example. So this is one more example. So it is a 3 carbon containing alkene. So it is called as propene. And in propene also we are having double bond, and break one bond, break the pi bond. In double bond, one is sigma bond and the other one is pi bond, right? So you have to break the pi bond and you have to add the hydrogen molecule like this. So you will get propane. Alkane is formed. Got it? Then I'll give one example for alkynes. So for alkynes, that is carbon-carbon triple bonded system, I have took propane as an example for you. Propane contains 3 carbons with the triple bond. So as I have already told you, 2 molecules of hydrogen has to be added here, right? So first you break the first pi bond and add hydrogen like this, okay? Then break the second pi bond and add hydrogen like this. So obviously what we have done, so to the second carbon, we have added 2 hydrogen, and to the third carbon, we have added 2 hydrogen. So it becomes CH3, CH2 and CH3 at the end, which is propane. Got it? So is this clear for all of you? If it is clear, if the first preparation is clear to all of you, just put a thumbs up or type yes in the chat box. If you're having any doubt, raise your hand. Sharmila is having any doubt? Or you have raised your hand for my question? You have understood or you have any doubt, Sharmila? So is the first preparation clear to all of you students? Waiting for your response. Yes. Okay. Thank you so much, dear. I don't know your name. You have joined from some other ID. Yeah. Yeah. Yes, Shivashankar. Yeah. Good, Ankita. Thank you for your response. So now let us move on to the second preparation of alkanes. Okay. So it is from alkyl halides. It is from alkyl halides. From alkyl halides, we can prepare the alkanes by 2 ways. Okay. The first way is by using zinc metal and dilute HCl, which is an acid. Okay. So zinc is the catalyst here. And from this acid, all the acid contains H plus ion, right? It is H plus and Cl minus. So you can see alkyl halide is taken here. R group is an alkyl group and Cl is the halogen. Fluorine, chlorine, bromine, iodine, they are halogens. And among those halogens, chlorine is taken here. So it is an alkyl halide. And R group is alkyl. You all know what is alkyl, right? Methyl, ethyl, propyl, those are alkyl groups. So to this alkyl halides also, we are adding this hydrogen molecule only, but in presence of zinc metal as the catalyst. Okay. And also using an acid from dilute HCl. So on using and on adding these things, HCl is getting eliminated. Who is getting eliminated? HCl is getting eliminated from the reactant side. Okay, HCl is getting eliminated from the reactant, and the second hydrogen is going and forming the bond with the alkyl group. Got it? So let us see an example. So I have to chloromethane as an example for you, and hydrogen is added here. So HCl is removed, and CH3 is bonded with H to give methane. Okay. So one more example I'll show you, chloroethane. So here this is your R group. Ethyl is the R group. So whatever may be the R group, you just add hydrogen to it. Whatever may be the R group, you just add hydrogen to it, you will get the product. Okay. So to C2H5, if you add one hydrogen, you will get C2H6, right? Very easy. Just read this general reaction alone. You don't have to memorize all the examples. Okay, don't memorize. Just study the general reaction. Okay, whatever may be the reactant given in the question paper to you, you can write out. You can get the answer from that if you are thorough with the concept. Okay, just the conversion alone you read. If I am using this particular reagent, this particular reactant is getting converted to this particular product. So in that way, you have to study. Okay, just the skeletal structure alone you have to study. You don't have to memorize all the reactions. Okay, and yeah, third example is given to you. It is 1-chloropropane. Here, propyl is the alkyl group, and to this alkyl group, add one hydrogen, you will get propane. Okay, clear? So this is the first preparation of alkane from alkyl halide, that is using zinc and HCl. So now, so shall I move on to the second preparation of alkane from alkyl halide? Is this clear to all? You guys are going to study only this. Okay. If I am taking the alkyl halide in presence of zinc and H plus, I will get alkane with the formula RH. That's all. So I'll move on to the next slide. Okay. If you're having any doubt in between, you can raise your hand or you can put it in the chat box at any time. So I'm here to clear you. So now the second preparation is Wood's reaction. So this is one of the very important reaction which you have to note it down. So it is a naming reaction basically, and from Wood's reaction, only symmetrical alkanes can be prepared. Very important. Only symmetrical alkanes. Okay. So what are symmetrical alkanes? Even number of carbon containing alkanes. Even number of carbon containing alkanes are called as symmetrical alkanes. Even number means 2, 4, 6, 8, right? Ethane, butane, hexane, octane. Only these kinds of alkanes can be prepared using Wood's reaction. Okay. Now, what is the reaction? What is Wood's reaction? So, in the Wood's reaction also, we are going to take one of the reactant as alkyl halide only. So, alkyl halides on treatment with sodium metal. So, here the metal is sodium. In the previous reaction, who was the metal? Who was the metal used in the previous reaction? What is the name of the metal used in the last reaction from alkyl halide? Yeah, very good, Anjanasri. You have joined later. Now only I'm seeing you. Yeah. Very good, very good, students. So it was zinc. So here the metal is sodium. In the first reaction, very good, Shivashankar. In the first reaction, which metal we have used? From unsaturated hydrocarbon, palladium, platinum, and nickel. So these metal catalysts you have to keep in your mind. The reactant and product conversion you have to keep in your mind. Okay. So here sodium metal is used in dry ether. Dry ether means the ether which is free from moisture. So there is no water molecule present inside the system. So they will give higher alkanes. Okay. So this is the general reaction for Woods. You can see alkyl halide is taken 2 moles. So 2 Rx is taken and the 2 moles of alkyl halide is reacting with the 2 moles of sodium. From here, 2 NaX is removed. 2 NaX is removed. So I'll show you the better visual. Okay. Just a second. Yeah. So 2 moles of 2 NaX is removed And now we are going to connect the 2R group. So just remove the 2NX and connect the 2 alkyl group. You will get RR. So in the previous reaction, we got RH. Okay. Using zinc, we got RH. But here we are getting RR. Okay. Just keep this in your mind. Just study this reaction alone. Now we will see one example for this. Okay. So I hope all of you have noted this down. Shall I move on to the example of Wood's reaction? Yes or no? Shall we see an example? All of you have noted it down, right? Shall we? Yeah, okay. Yeah, okay. Thank you. So I'll give you an example. So you can see, I have took bromoethane as an example. So 2 moles of bromoethane I have took, and now this is going to get treated with sodium metal in dry ether. So can anyone give me the name of the product from this reaction? What could be the product for this reaction? You don't have to type the formula. Just give me the IUPAC name of the product that is obtained from this reaction, from bromoethane. It's very easy. Bromine. Bromine. What is bromine, Anjanastri? We don't have any compound like bromine, okay? Yeah. Good. So typing mistake. No problem. No problem. Good. It is butane. Very good. So 2NaBr is removed and we are getting 2 alkyl groups are joined together by a carbon-carbon bond. So we are getting a butane. Very good. Very good. So 2NaBr is going out. And for this particular reactant, for bromomethane, what could be the answer? For bromomethane, what is the name of the product from bromomethane? From bromomethane. Can anyone try for this? Yeah, good, good. Answer is ethane. Answer is ethane. So you can check. So if we are taking a 1 carbon containing alkyl halide, if you are taking 1 carbon containing alkyl halide, 2 carbon containing alkane is formed. And in this example, we have took 2 carbon containing alkyl halide, but in the product, how many carbons are formed? 4 carbon containing alkane is formed. If we are taking 3 carbon containing alkyl halide, then we will end up with 6 carbon containing alkane. If we are taking 4 carbon containing alkyl halide, we will end up with 8 carbon containing alkane. So what is the sequence we are getting? We are getting only the even number of carbon containing alkanes as a product. Okay. So this is the Woods reaction. Got it? So this is the second reaction. Now I will move on to the third main category for the preparation of alkanes. So this is clear, right? Is this reaction clear for all of you? Just keep the metal in your mind. And one more thing you have to keep in your mind. You have to take 2 moles of alkyl halide. Okay. You have to take 2 moles of alkyl halide here. In zinc, if you are using zinc, there you are going to use only 1 mole of alkyl halide. But for Woods reaction, you have to use 2 moles. So this 2 moles and the metal sodium you keep in mind. So I think we can go for the third reaction. So the third reaction is from salts of carboxylic acid. Carboxylic acid salt we are going to take, and from that salt we are going to prepare the alkane. So under this also there are 2 categories. The first reaction is decarboxylation reaction. So what is meant by decarboxylation? It is nothing but the removal of, it is the removal of Na2CO3 or the removal of CO2. Okay. Removal of sodium carbonate or the removal of carbon dioxide is called as decarboxylation reaction. Okay. So now we are going to take the salt of carboxylic acid. Before moving on to the salt, we should know what is carboxylic acid, right? So can anyone give me the formula for carboxylic acid? Just the general formula. General formula. You don't have to give any examples. Just give me the general formula for carboxylic acid. In the last lesson, we have studied this, right? in all the functional group topic and its priority, and while studying the nomenclature we have discussed this, no? What is the general formula for carboxylic acid? Can anyone, any of you remember the formula? CH3CO. Yeah, this is one of the example for carboxylic acid. Very good, Shivashankar. So the general formula is R COOH. This is the carboxylic acid. Okay. Now, if I am replacing this hydrogen by sodium or potassium, I will get RCOONE. RCOO minus Na plus. Like this I will get. Now this is called as the salt. Salt means usually plus and minus should be there, right? We are calling NaCl as the salt. Why we are calling NaCl, sodium chloride, as the salt? Because it contains positive and negative ions. So if a compound contains positive and negative ion, then it is called a salt. Now this compound is called as salt. It is a sodium salt of carboxylic acid. Sodium salt of carboxylic acid. So we are going to take the sodium salt of carboxylic acid as one of the reactant, and to this reactant a mixture is going to get added. Okay, that mixture is NaOH and CaO, sodium hydroxide and calcium oxide. This mixture is called as soda lime. This mixture is called as soda lime. On addition of this soda lime mixture to the sodium salt of carboxylic acid, Na2CO3 is going to get eliminated. I told you, no, removal of Na2CO3 is called as decarboxylation. So how we are going to remove that Na2CO3? Just have a look in it. I'll just use different color. Yeah. So Na2CO3. That is this actually, Na2CO3. Okay. Na2CO3 is removed and R is going to form the bond with H. R is going to form the bond with H, and this RH is nothing but the alkane, right? So this reaction is also called as step down reaction. Why it is called a step down reaction? Number of carbon atom the product will be decreased. Okay, if we are taking a 2 carbon containing salt here, we will end up with only 1 carbon. Why? Why we are ending up with 1 carbon? The second carbon is going to this compound as Na2CO3. Okay, so 1 carbon is reduced. So the name of this reaction is otherwise called as step down reaction. Okay, let us see an example to understand this reaction better. So I'll give you an example. Yeah. So here I have took sodium salt of ethanoic acid. Ethanoic acid is CH3COOH, right? So on removing or replacing hydrogen with sodium, I will get this CH3COO minus and Na plus, ethanoic acid salt. So it is treated with soda lime. Now, what will be the name of the product? Na2CO3 has to be removed, right? So this is Na2CO3. This part is getting removed, and this alkyl group, which is CH3, is now going to form the bond with hydrogen. So what I will get? I will get CH4 plus Na2CO3. The name of this alkane is methane because it has only 1 carbon. Got it? So now you can see, we took 2 carbon containing compound, but we have ended up with only 1 carbon. Got it? So that's why it is called a step down reaction. I will give you one more compound as an example, and you guys try to find out the name of the product, name of the alkane from this reaction. So this is the sodium salt of butanoic acid. And can you give me the answer? Can you give me the name of the alkane from this particular reaction? What could be the name? If you remove Na2CO3 from this 2 component, what you will get? It's very easy, right? Propane? Yes. Very good. It is propane. Very good, Anjanasri. So we are removing this Na2CO3 and the alkyl part is propyl here. And to this alkyl group, we are going to add this hydrogen and we got propane. That's all. Very simple and very easy. Okay. So now let's move on to the second preparation of alkane from the salt of carboxylic acid. So the first reaction under this is decarboxylation. Now let's go for the second reaction, which is called as Kolb's electrolysis. Which is called as Kolb's electrolysis. Again, it is one of the very important. All the preparations, all the reactions of this hydrocarbons lessons, they are very, 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 very important. Okay, this lesson is having the high weightage, like GOC. This lesson is also having high weightage. Okay, so you have to concentrate on both the organic lessons of your class 11. Got it? So Kolb's is again a naming reaction. So that's why I have told it is very important. So otherwise all the reactions are important only. Now you see what is meant by electrolysis first of all. Electrolysis is a process where you have a beaker, which you can see on the screen, and in the beaker we are having one solution here. So that solution is called as electrolytic solution, and to the solution two electrodes are dipped into it. One is called as anode and the other one is called as cathode. The charge of cathode is negative and the charge of anode is positive, and they are connected to the terminals. Okay, now if I switch on, so movement of electrons or movement of ions occurs inside the solution, and the product will come and deposit. They will come and get deposited on the surface of the electrode. Okay, this is called as electrolysis. Kolb is the name of the scientist. He also used the salt of carboxylic acid as one of the reactant for his reaction. Okay, so he took the same sodium salt of carboxylic acid, but 2 moles he took, and he took the salt and put that salt into the water. So water is added, and on electrolysis, he got RR alkane with the removal of CO2, NaOH and H2. So this is the general reaction. So from Kolb's electrolysis, we are going to get four different products, but among those four, only one is the alkane. Okay, of formula RR. In decarboxylation, we got RH. In Kolb's electrolysis, RR. But the reactant is same. Sodium salt of carboxylic acid. Okay. Now, this reaction is called as alkane has twice the number of carbon atoms present in the alkyl group. So you see, this is the alkyl group. If let me take this alkyl group as CH3. Okay. But in the product, we have two alkyl groups connected with each other. So this is also CH3 and the other one is also CH3. In the reactant, we have only one carbon, but in the product, we are having two carbon. So what is happening? Alkane is having twice the number of carbon atoms present in the alkyl group of the acid. Okay. These are all the topic concepts you have to keep in your mind. Okay. And carbon dioxide, sodium hydroxide, hydrogen, they are all coming out, no? So among these three, carbon dioxide and hydrogen is gas. So carbon dioxide is released at anode and hydrogen is released at cathode. Okay, these are also very important point. You have to keep a note of it. They will give you some four options and they will ask you to find out the compound that is being released at anode or the compound that is getting released at cathode. So you should be able to answer. Carbon dioxide at anode and hydrogen at cathode. Got it? So now let us see some example for this Kolb's electrolysis. Shall I move on to the example? Did you all note it down? All of you? Shall I go for the example? Yes or no? Okay. So let us see an example for this electrolysis. So here sodium salt of ethanoic acid is taken as an example. So can anyone guess the product? Can anyone guess the product from the concept I have taught you in the previous slide? Can anyone guess the name of the product? So here the alkyl group is CH3. Alkyl group is CH. This is R. So R should be the product. So methyl, which is nothing but ethane. The product is ethane. That's all. Okay. So it's a very easy preparation. So now I want to ask some questions to you. So that's all. With this preparations of alkenes gets over. Okay, let us see some questions and then I will summarize this preparation and we'll move on to the next topic. Okay. So here is the question to you on the screen. Which of the following compound on treatment with soda lime will produce propane? Which of the following compound on treatment with soda lime will produce propane? What is soda lime, students? It is the mixture of sodium hydroxide and calcium oxide, right? So this is the soda lime mixture. And the name of this reaction is also decarboxylation reaction, right? It is also called as decarboxylation. Now you have to find out the compound that produce propane. So I'll give you some 15 to 30 seconds to solve this question. So one of you have to give me the answer. Option A. Option A. Okay. Option A. Okay, let's option A is correct. So if I am taking option A, you see the name of the product. What is the product I'm getting? I'm getting CH4. I'm getting CH4. Decarboxylation, I told you, right? Na2CO3 will be released. Na2CO3 will be released and the CH3 is going to form the bond with H. That's all. It is giving CH4. But in the question, what they are asking? They are asking the formation of propane. They're asking the formation of propane. In the first option, we are getting methane. Now, among the remaining three options, can you tell me the correct answer? Can you tell me the correct answer? I don't know why all of you have chosen option A. Among the remaining three, which is the correct answer? Option C. Very good. Option C is the correct. In option B, you see, here is the alkyl group. Yeah. But all of a sudden, all of you have given me option A. Why and how? Huh? All of you have given the wrong answer first. I don't know how and why. Okay. In option C only, we are getting propane. Removal of Na2CO3 leads to the formation of propane. Okay, this is called as propane. And in option D, what we get? We get butane because alkyl group is butyl, right? So we get butane, and in the third reaction only, we are getting propane. So option C is the correct answer for this question. Okay. Yeah. Now let me summarize the preparation of alkane for you all. So majorly we had three main category, and from unsaturated hydrocarbon, from alkyl halide, and from salt of carboxylic acid. So here both are unsaturated compounds and both gave alkanes using which metal? Which metal we used here? Nickel, palladium and platinum, right? So these are the metals we used with the addition of hydrogen. So the same group you have to use for alkynes also. And this reaction is also called as hydrogenation. Why it is called as hydrogenation? Because we are adding the hydrogen. Addition of hydrogen is called as hydrogenation. Okay. Then from alkyl halide we saw two reactions. One is zinc, and the name of this reaction is called as, yeah, there is no such name, right? Sorry. So it is zinc and HCl. And here we took alkyl halide, okay, and we used zinc and HCl as the acid, and at last with the addition of H2 also, okay, we got RH with the removal of HCl or HX. And in the Woods reaction, what we did, we took 2 moles of RX and we used 2 sodium in presence of dry ether, and we got RR with the 2 NaX. Okay. Now coming to the third preparation, one is decarboxylation. So what is decarboxylation? Here RCOO minus Na salt was used, and the soda lime mixture, which is NaOH and CaO was used, and Na2CO3 is one of the byproduct, and the main product is RH. Okay. And in Kolb's electrolysis, 2 moles of the same sodium salt of or potassium salt of carboxylic acid is taken with water. Okay. On electrolysis, what we got? We got R. That's the main product. So this is what you are going to study. This is what you are going to keep in your mind. Got it? So this is a summary of the preparation of alkenes. Got it? Now I will move on to the next topic, that is the physical properties of alkenes. So students, do any of you have any doubt in the preparation part? So I hope all of you will go and study this again back. Okay. So all of you have to go back and study. So every day, I told you in the last class itself, every day you have to study organic chemistry. Okay. If you study this organic chemistry every day, it is going to be very easy for you to get good marks in your chemistry. Got it? So I don't think you guys have doubt on this. If you're having any doubt, just raise your hand. Okay. I will move on to the next topic, that is the physical properties of alkenes. What is meant by physical property? The properties which can be measured by seeing or using an instrument, or which can be measured or using instrument, using weighing machine, those are called as physical properties. So the first physical property of an alkane is all the alkanes are non-polar in nature and they are hydrophobic in nature. Hydrophilic means water loving. Hydrophobic means water hating. What is hydrophobic? Hydro means water and phobic means repelling nature. So all alkanes are having water repelling nature and they are non-polar. Polar means the separation of plus and minus charge in the compound. Non-polar means there is no such plus minus separation between carbon and hydrogen in alkanes. Okay, you can see here. So hexane is the alkane and this alkane is not getting dissolved with water. They are water repelling. They will not get dissolved with water. Okay. So this is about the first physical property of alkane, and the second physical property is they are immiscible with water. Immiscible means they are insoluble with water. Okay, solubility nature is they are insoluble in water. Got it? Now coming to the next property, at room temperature, that is 298 Kelvin or 25 degrees Celsius. At room temperature, carbon number 1 to carbon number 4. They are the physical nature of these alkanes are gases. They are gases. Carbon number 1 means methane, ethane, propane and butane. These 4 alkanes are gases at room temperature. And from carbon number 5 till carbon number 17, they are liquids. The nature is liquid. So in we are having petrol, diesel and all, right? So what is the nature of petrol? Nature of petrol is liquid, right? It is a hydrocarbon. Petrol is a hydrocarbon. Octane and nonane, such kind of system is used there. So octane contains 8 carbon, right? So it is greater than this. Called they are liquids. Carbon 5 till 17 are liquids. So that's why petrol is a liquid. And from carbon number 18 onwards are solids. Got it? So this is the physical nature of the alkanes. So carbon 18 onwards means, what example I can give you? I can give carbon 25. So carbon 25. 25 carbon containing hydrocarbon is a wax. So it is a wax, which is a hydrocarbon. 25 more than 25 carbon containing hydrocarbon. That's why wax is a solid. Wax is a solid. Okay. Yeah. This is about the physical nature, and all the alkanes are colorless and odorless. So no smell, no color. The very important physical property of alkane is the boiling point. So you can see the boiling point increases with increase in molecular mass. So what is the relation? Boiling point is directly proportional to the molecular mass. So you are going to use this relation if the molecular masses are different for two compounds. If the molecular masses are different for two compounds, then you have to use this relation. The one which is having the highest molecular mass will have the highest boiling point. Okay. For equal carbon atoms, what is meant by equal carbon atoms? For isomers. For isomers, the molecular formula is going to be same, right? If the molecular formula is same, molecular mass is also same. So they will have equal number of carbon atom. So in that case, how will you find out the boiling point? So it decreases with increase in branching. It decreases with increase in branching. So boiling point is inversely proportional to branching. If other one will decrease. So this second relation you are going to use if the molecular masses are same. If the molecular masses are same. Okay. You see the boiling point of straight chain will be more than the boiling point of branched chain, because it is inversely proportional, right? The one which is having very less branching or no branching boiling point. So that is why straight chains are having the highest value compared to the branched chain. Clear for all? Any of you have any doubt in the physical properties of alkanes? Any of you have any doubt here in the physical properties? If the molecular masses are different, use the first relation. If the molecular masses are same, use the second relation. So let us see some examples to understand this better, okay? Don't worry. Now I'll give you one example. So now compare the boiling points of N-pentane, isopentane and neopentane. What is the correct increasing or decreasing order of these three compounds for boiling point? So for this, we should know the structure first. We should be able to draw the structure of all these three compounds. So the first compound, this is N-pentane because it has 5 carbon. Right, it is N-pentane. Pentane is nothing but 2-methylbutane. 2-methylbutane is called as isopentane. Isopentane is the common name. 2-methylbutane is the IUPAC name. And neopentane is the common name. What is the IUPAC name of neopentane? IUPAC name of neopentane? Or I'll give you the structure, you try to find out the name. What neopentane? What is the IUPAC name of this compound? Can anyone try? Can anyone try for this? What is the IUPAC name? Parent chain is also given to you. It is 1, 2, 3. And to the second carbon, we have 2 methyl groups, right? So what could be the correct IUPAC name for this? It's very easy. Why are you taking so much of time to answer this question? It's so easy, na? What is the answer? It is 2,2 dimethyl propane. That's all. 2,2 to the second carbon, we are having 2 methyl groups. So it is 2,2 dimethyl propane. Okay. So revise all the nomenclature part. Every day I'm telling you, go and revise again and again. Okay. Now, the structures are given to you. Now, which one will have the highest boiling point value? All the three compounds are having same molecular mass. If you can check for it, so all the three compounds are having 5 carbon and how many hydrogen? 12 hydrogen. Okay, all the three compounds are having the same number of carbon and hydrogen. So they are the. If the molecular masses are same, then which relation you have to use? Branching relation, right? So the boiling point is inversely proportional to branching. So this relation only you are going to use. The compound which is having the very least branching will have the highest boiling point. So among these three compounds, N-pentane is having 0 branch and 2-methylbutane is having this 1 branch and the last compound is having 2 branch. To the parent chain, we have 2 branches. So N-pentane will have the highest boiling point value, then your second compound, then your third compound. Clear for all? Clear for all? Yes or no? Now I'll ask if I'm having butane if I'm having and butane, CH3, CH2, CH3, and CH3, CH2, CH2, and CH3. So for these, among these two compounds, which one will have the highest boiling point? Tell me. Among these two compounds, this is compound number 1, this is compound number 2. Which compound will have the highest boiling point? Yeah, Shivashankar. Actually, it is a printing mistake. Sorry for it. It is actually 3. CH3. Okay, it is coming at the terminal, no? So it is 3. So each carbon should have 4 is bonded with the carbon, the remaining 3 are hydrogen. Yeah. So other students, can we all try for this? Yeah. Can anyone try for the answer? Among these two compounds, which one will have the highest? Compound 2. Very good, Anjanasri. Because the molecular mass is different. Molecular mass is different because the number of carbon atoms is differing. Yeah. So if the molecular masses are different, then the one which is having the highest molecular mass have the highest boiling point, directly proportional, right? So compound 2 will have the highest boiling point value compared to compound 1. Okay. So that's all about the physical properties. So today we have discussed the preparation, and 3 preparations we have discussed, and some of the physical properties we have discussed. And among the physical properties that we have discussed today, boiling point and the two relations under boiling point which we have discussed is very, very important. And the solubility is very important. They are immiscible with water. Okay. So these 2 points are very important under physical property. Tomorrow, yeah, it's 3:55. Tomorrow we will discuss the chemical properties of alkenes. Okay, we have some 7 reactions, 7 chemical properties of alkenes. So those reactions we will discuss tomorrow, and we will solve some questions on it also. Okay, so try to join on time. Try to join at 3 o'clock. Then only we can cover many topics. Okay, so you can study for it and you can revise it. So try to join on time. Okay, so if you're having any doubt, you can ask. Any of you have any doubt in today's class? If any of you have any doubt, you can put it in the chat box. Everything is clear to all of you? If everything is clear to you, just put a thumbs up. No? Okay. Okay then. Thank you so much for listening the lecture, students. Take care. See you all tomorrow. Bye-bye. Yeah. Thank you.